Hello, Tom from Every Step Physics, EveryStepCalculus.com. Physics problem regarding planets, because they mention planet in the problem, and they're categorized in my programs into a certain planets in the menu. Press Physics to get to my main menu, which you put in there. That's all in the instructions in my programs when you purchase them. I'm already at planets to save time. Otherwise you'd scroll down from the menu from the A section down to the P, and we're asked to find the mass of the planets, so we need to go to a little bit more complicated problem. We're going to go down here to G, which is mass, and then what's given? Well, it's radius and acceleration in this one, so we're going to press number 2 or scroll down to it the cursor, and I gave you the gravitational constant. Always write it on your paper so you know that. It's in all these planet formulas generally. We're going to enter the radius. You have to press alpha first in my menus, or my entry lines. Alpha 6 times e to the 6 divided by 2. Now you notice this is 6,000 kilometers. Well, kilometers is 3 zeros. 6,000 plus 3, so that's 6 zeros. So it's 6 times e to the 6 power in scientific notation. You could put 6,000, and then I would convert it kilometers to meters for you in my program. But this one I'm just going to keep it like this because I've been used to it. Entering it with the scientific system. Press enter, and we're at number 3 meters, and we're going to enter the acceleration, alpha 8 meters per second. Show you what you've entered. Now remember, acceleration in planets is the same thing as gravity, G, gravity, which we're most used to using. The force of gravity, like force, mass times gravity is the force of gravity. And so I say it's okay, and we do the calculations. Here's the original formula for acceleration, and then through the magic of algebra, we pull out the mass, m, and transpose the other items to the other side, and then enter the variables and calculate it. Here's the answer, 1.0795 e to the 24 kilograms. That's the mass of this planet, okay? Press enter. New problem. Press enter. Now we're going to go to find the given the problem, find free fall acceleration. So we're going to go down here to number 9. And find the acceleration. Choose that one. And it's another planet, not Earth. Choose that one. But I do give you the radius of the Earth and the mass of the Earth here as a reminder, because sometimes in the problems they might give you, well, the other planet is 3 times the mass of the Earth, or 4 times the radius, or whatever they dream up to give you on these problems in physics. So I gave you that, no big deal. They give you ask for the height above is there a height above the planet? And I say yes, because they're giving it to you here, 9,000 kilometers. So we say yes, so we enter the height, alpha 9 times e to the 6 meters. Number 2. Excuse me. There's the height above the planet. I say it's okay, number 1. And we're going to enter the mass of the planet that we found, okay? That you wrote down on your paper. Alpha 1.0795 times e to the 24 power. kilograms, of course. Show you what you've entered is good. We're going to enter the planet's radius, alpha 6 times e to the 6th power divided by 2. Number 3. And then you have to add the radius of the planet to the height above the planet, because everything's done from the center of planets, center to center. So I do that here, 1.2 e to the 7 meters. Now we've come up with the radius, r here. Gravitational constant, the mass of the planet here, and the radius squared, okay? Turns out to be 0.5 meters per second squared. Pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs, and enjoy passing physics. Otherwise, enjoy suffering yourself by not having these programs and studying it yourself, okay? Extremely difficult, especially calculus. All right, have a good one. Good luck in your classes.